A challenging example here with addition of rational expressions where the denominators are not simple monomial terms, but a bit more involved. We have a binomial in the x squared minus 9, and then we have a simple trinomial. So before we add these, we need to factor out both denominators. So I'm going to start with the first one. The numerators are actually quite simple for a change. And if I realize that this is a difference of squares, I can write x squared minus 9 as x minus 3 and then x plus 3. And that's all plus 3 over, okay, I recognize this is a simple trinomial. I'm looking for two numbers that add to give me -4, multiply to give me +3. The numbers are -3 and -1. Now in order to add these, we need to have common denominators. You'll notice that both fractions have the x minus 3 in them, but the first one doesn't have x minus 1, and the second one doesn't have x plus 3. So what that means is that we're going to have to alter each fraction by adding the appropriate factor to both numerator and denominator. So here we go. I'm going to take my first one. I'm just going to copy it out. And what I want it to have, let me put it down here. What I want it to have is the missing factor in the denominator. And that happens to be x minus 1. So I'm going to multiply the numerator by x minus 1 and the denominator by x minus 1. And as for the second fraction, I need it to have the x plus 3 term. So here, I'm going to have a plus sign in the middle, but I want it to have x plus 3. Again, I'm writing the stuff in blue to indicate the changes that I'm making to each fraction. Excellent. So now you have identical denominators. Again, the order is different, but remember, when you multiply numbers, you can commute the order. In other words, you can interchange one with the other. It will have no effect on the final product. And we can combine our numerators together. So our line here is going to be 2 times x minus 1, close bracket, plus 3 times x plus 3, close bracket, all over our common denominator. So x minus 3, x plus 3, and x minus 1. At this point, I may as well just indicate my restrictions. So x can't be +3 from here, x can't be -3 from here, and x cannot be 1. So x cannot be 1 and plus or minus 3. Now the hard work is done. All that's left is to multiply out the numerator. And in this case, what I'm going to do is I'll do 2 times x, 2 times -1, 3 times x, 3 times 3. And to save myself some time, I'm just going to copy this whole thing because I want to keep that denominator. That's not going to change. Paste it here. And I want to delete all this stuff because that's what I'm going to expand. So what do I have? I have 2x minus 2 plus 3 plus 9. That's 3x plus 9. Like terms, well, the 2 and the 3x combine to give me 5x. So one last time, let me paste this over here. Again, I'm going to delete my numerator. Denominator stays the same. So 2 and 3 gives me 5x. And -2 and +9 gives me plus 7. And that's it. Okay, there you have your combination addition of two rational functions with a simplified numerator, and I'll leave the denominator in factored form just so you can see the restrictions clearly.